Hi all. This is series 11. This is my new series here, and I will cover in this series service mesh and implementation of service mesh is Istio and Linkerd. And both thing I will use for that EKS cluster that I will create on the AWS. And apart from that, I will cover Amazon managed streaming per Kafka, that is MSK service for AWS. So I will cover both things in this series, and this is series 11 part 1 video. And here I'm going to discuss that introduction. For that introduction means whatever topics and video I will cover in this series 11, then we are going to discuss. And in the brief introduction for that, for those next videos, next part. And also I will explain something about something brief in 5 to 10 minutes in the service mesh and discuss Istio and Linkerd implementation for that, right? So this agenda for that discussion for that, this is a part 1, video part 1. We are currently discussing on the introduction, and I will cover later part of this video service mesh. And in this part 2, I will cover that how to create the EKS cluster using EKS CTL command, that is things. And before that, I think in my last video, that is a part 1, series 1. Let me open series 1. That is my series 1 video. I will provide this link for this playlist in this description of this video. You will get it. And here you can see I have already covered that in part 2, installation of Kubernetes cluster with manager and node using command line. Here we have a full access of the manager because we are created in both cluster in with manager and nodes. So I've covered in both things in already covered in AWS and GCP. This is the first type of creating the cluster, and second type is we can use the services directly pass services in GKE for in GCP and EKS in AWS. That I've already covered. This is second type, you can say. And third type I've covered in the series 2. This is series 2. I've covered in series 2, part 6. Setup of Kubernetes cluster using KOPS in AWS. And same thing, I've covered this Kubernetes cluster KOPS using KOPS in GCP. That is in series 2. I've already covered those things. Now, in this series, I'm going to cover creating EKS cluster using EKS CTL command. And in the part 3, I will explain how to installation and configuration Istio on EKS cluster, and how to see those graphs in Kiali and Eager, those things. And I will going to use that book info application for that. One example for that I will take. And that EKS I will take those cluster which I've created is already in that part 2, right? And in part 4, same thing, I will cover same installation as to an EKS cluster, but I will use the boutique application. This application is different only in this comparison of only application are different. Only everything is same. Only application is changed, right? And the same EKS I will use over here in this cluster, right? And next part 5, I will go and discuss on the Linkerd, and I will show the graphs with the Linkerd with Grafana, and I will going to use the application Emoji Photo application. And this EKS, I will use the same EKS cluster over here, which I have created in part 2. So basically, this part 3 and part 4 are based on that Istio based, and part 5 based on the Linkerd. But that cluster, this cluster we are going to use here, we are going to use in this portion also, and we are going to use this portion also. Same cluster I will use in this all 3 videos, right? So after that, I will discuss in part 6 some event-driven architecture and what is AWS MSK, Kafka. That is some theory introduction only, and I will cover here it 5 to 10 minutes for theory portion. And next in part 7, I will cover some practical how to provision use this MSK cluster. That MSK cluster is different two type basically. So one is provision type I will cover here, and second type is serverless. So I'm covering both in later parts. So here MSK cluster will use a producer and consumer. So what we will do, I will do here, I will create one producer who will produce the messages with Kafka, and here we will use the Kafka, and we have a two consumers C1 and C2, and this consumer will pull the message from this Kafka. So this is the portion I will cover here. And in the next part 8, I will use that same MSK cluster, provision MSK cluster, and using the Python code for running this producer and consumer. And also consumer will take the data from the Kafka and push those data to the database server, MySQL and PostgreSQL. Both are the RDS I am using. So it is a diagram is just like this is producer, and it is just producing the messages from the some file. This is a file where it will take input from that and produce this message to Kafka, and it will, and this is a consumer one, will take the data from here from the Kafka and insert those data to the database, that is SQL, this one. And same I will show you how to, this is a consumer 2 will take data, same data from Kafka and push stored data to the PostgreSQL. So those this example I will cover in this part 8. And part 9, I will use this server type serverless MSK cluster. I will show you how to create serverless MSK cluster, and with same producer and consumer. I will take the same example here, what I've covered in part 7, and same thing I will use in part 9. And only difference, I will use the cluster, cluster type, serverless, and this is a provision cluster I will use, right? So I hope it is clear to you to just brief introduction for our series, my series 11 for that. And now, what is the prerequisite for this slave? This is we have must AWS account, access on the GitHub account, or we have our own GitHub account, basic knowledge of microservices architecture, basic knowledge of Docker and Kubernetes. So that is required for that. And GitHub repository, I am currently using two repository I've created for that. First for the service mesh Istio, that is for the service mesh, and where I've added all those files which I've used this demo. You will get it here. And second repository I've used that I will use MSK Kafka. That is, I will put all those files which I will use in the second part of the related to Kafka. You will get all those access in this URL, right? So this is the introduction for what is the service mesh. So before that starting, I will give the brief intro why we are going to use this service mesh, why it is required, what is we were facing earlier. So, we are creating earlier the monolithic application. Now we have moved to the microservices architecture. Then in microservices architecture, we are facing multiple issues. So I'm just going to explain those things first. Suppose I'm taking an example for that. Suppose we're creating any microservices based application and deploy it on the Kubernetes. An application is running fine, and but we will face multiple challenges later on when microservices size will increase, multiple pods will created over there. Then we will first issue what we will face here. Suppose we have two microservices may running on the same machine on different machine. So what is the communication? Communication between the two microservices in plain text, which is the problem. Because we providing the security like firewall at the outer level, not on the inside of the that ports for that, right? So second issue is no way we have a control that which microservices will communicate with which microservices. By default, any microservices can talk to any microservices. This is second issue. Third one, how to do traffic splitting. This is third one. And fourth one is how much load is getting on microservices. Like how much load is on the payment gateway microservices, how much load in the checkout microservices, and how much load in other microservices, right? And major issue is we are getting how to collect the matrices for that and tracking for each microservices. So this problem mainly occur we are using on the larger scale 100 microservices, 500,000 microservices we are doing, then this issue we will face like this issue in the later on. So the solution for all this problem is service mesh. This is service mesh, right? So this service mesh is providing a solution for all those problems which we have discussed earlier, right? So service mesh is just a pattern here. And implementation of service message, you can say this is Istio, Linkerd, console, AW, app mesh, schema. This all those are implementation of the service mesh, right? So service mesh is dedicated infrastructure layer of facilitate service to service communication between the microservices on any services, right? And it is mainly using the proxy. I will discuss with that on proxy more in later slide. It provides a dedicated communication layer and benefits like observability, the major benefits, secure connection, backup for failed request. These are the major benefits you can see for this service mesh. Service mesh is usually implemented by providing the proxy instance, which is called the sidecar. So sidecar is created for each service instance. Suppose we have a 50 microservices, then it will service mesh will create the 50 sidecar for that, right? I will show you diagram in the next slide for that. Sidecar handles inter-services communications, monitoring, and security-related concerns, right? So what does service mesh do mainly? What things we will get from service mesh? So we will get service discovery, load balancing, intelligent routing, encryption, very good feature for that. Monitoring and tracing, this is a major things we will get it here. Quality, quickly identify issues, authentication and authorization between the services. Resilience, service mesh is a solution because it resides outside the application. It means this application is, suppose this is our pod is running, this is our pod and our container is running over there, right? This is our business logic we have written over there. And when we implement this service mesh, its proxy container will created in each pod. This is a proxy. And proxy is just in the form of the envoy proxy. And this proxy contain everything, whatever feature I am discussing here. This is the proxy contain everything. We don't need to change anything in that our application. And proxy will communicate with that our application, right? So we will provide the more picture in later slide, right? Here you can see this is a sidecar which I'm and this is our primary application, right? And here you can see our business logic is written here. Our developer is only responsible for the writing the business logic, which is our primary application. And when this sidecar is implemented over here, it will provide that communication configuration, security logic, retry logic, metric capability, tracing capability, and it work as a proxy. right? So extend the main container functionality without any impact. Sidecar container are the container that should run along with the main container in the pod. So so this is a pod and it is running with the main container and communicating with the between it, right? Sidecar pattern extend and enhance the functionality of the current container without changing it, right? We are getting so much functionality for that without changing anything in our core functionality, right? So this is the pattern for that. This is a control pan, and this control panel it can connect with the proxy, each proxy which is injected in that pod, and our services is running like that. So proxies communicate to our service, and services sending request response back to the proxy. So it is running like in this manner, right? All those pods. And this is a network layer. It is creating our own network with the proxy for that and controlling everything with this network layer, right? So what is the Istio? Istio is open source service for the Kubernetes. Service mesh I told is a pattern, and Istio is one of the implementation. We will cover Istio and Linkerd, two things over here, right? So Istio is powerful feature provided a uniform and more efficient way to secure, connect, and monitor services, right? Istio is the path of the load balancing service to service authentication and monitoring with few or no service code change. This is the main feature. And this is the main feature for the Istio, which we have discussed for earlier previous slide for that same thing. It is providing here service to service communication, authentication and authorization, load balancing, fine-grained control on the traffic behavior, rules, retries, failover and fault injection, and pluggable policy layer and configurable support, access control, rate limit and quotas, and automatic metrics log and trace. Tracing is very important here, right? Over there, we're getting those things. Oh, 1 minute. Now, you can see this is the one of the property, a good property for the traffic splitting for this Istio. Suppose we have a web server services are running. We have created a newer version that is a 3.0. We have created 3.0, and the previous version 2.0 suppose is running right now. We can split only 10% traffic to the newer service and rest of the 90% to the older one. And later on, we can increase this. If everything will run fine, then we can increase slowly. So release new version without worry about the breaking the application, right? And this is also called the canary deployment, right? Now, how a traffic flow happening in the Istio is the requester send the request to the Istio gateway. It is receiving that thing and it is using the virtual services. Virtual services contain the details for internally how to flow this traffic from this gateway to the pods, right? So suppose showing in the 3 pods over there, web server, payment, and database, how it will flow. It will return the virtual services, and it calls the envoy proxy of the next pod, and this proxy is communicate with the actual service and get the response from service, and based on the virtual services and destination rule, it is calling the other pod. So this two proxy between the two pods is running creating that mTLS connection between that. It is a secure connection, and we will discuss mTLS detail in the later slide, right? So this is the connectivity flow for that. And next slide, it is using the ingress gateway for that, and ingress gateway is the input for that, entering those requests from the client cluster request coming in the ingress gateway. It is just alternate of the Nginx ingress controller, and gateway direct traffic to the microservice using the virtual services, right? So it is the same structure. You can see here we are using the Istio. We will discuss in the architecture diagram for the same, and it is a combination of the three multiple components, and it is running same way the envoy proxy, and envoy proxy is communicating with the services, and again based on that virtual service and destination rule, it will move to the other pods and communicating it with that, and basically it is controlled by the Istio service. And this core feature we have discussed earlier, traffic management. It is a intelligent traffic routing we discussed in last slide, flow control, request routing, and load balancing. Multiple features are for that. And setup, retries, circuit breaker, timeout, and fault injection, ingress and egress. This comes on the traffic management. And security feature, it is just providing the certificate management, means contain own certification authority. So it means it is providing certificate to the proxy server, right? And mTLS communication for that. And access control, authentication, authorization, it is all handled in this security feature. And the next good feature is observability, where it is a robust tracking, monitoring, logging feature that is using the Prometheus, Grafana, Eager, and Kiali dashboard is very good dashboard where we will get all those things details over there. So later I will share, I will show you how in the practical lab how to open, create the install the Kiali dashboard, how to open, and how can we track the details for the microservices, right? So this is the Istio architecture. You can see this is the main component. It's divided into two compartments. This is the control plane and the data plane. And the main feature of control plane is TOD is a major service. It is a combination of all three other services. In earlier it all comes in different part, but in later Istio is combined all those in the one box with and controlled by the STOD, all those things. And it is providing the certificate from to the proxy server. Sorry. And from this, it is generating the CA. It is a CA authority over there, and the CA manager is there. So it is creating that generating certificate and providing to each proxy, and controlling those, and that those connection is secure. So this is the two services, service A and service B, both are connecting via the proxy. They are not directly connecting. This is not doing, right? They're connecting with the proxy servers, right? So details I have provided here in the slide for each component. So similarly in the Linkerd architecture, it is different for the CLI only. It is controlled for the CLI. And Linkerd proxy side using the Sidecar here, using the Linkerd proxy that is provided by the Linkerd, and it created the Linkerd namespace for that, and everything it is managed by Linkerd namespace. And same thing, it is communicating with Linkerd to Linkerd proxy to other pods for Linkerd proxy. Same thing here, and our application is running here. Similar way it is running. And it is a multiple components over there in control panel, right? So details are there, like Linkerd CLI typically run outside the cluster for that, right? Where I will show you in the our demo. I'm using the Git pass for using the CLI for that Linkerd, right? So this is different. I have a comparison. I have added here about what is difference mainly in these two and Linkerd. This is based on the features, multiple features, e.g. installation, platform, supporting protocol, ingress controller, service mesh interface, resilience, security, routing features and performance. All those what are differences for that. Just for the knowledge purpose, I have added here. If you want to check it out, you can check it here, right? So now this is the TLS. What is TLS for the transport level security? So TLS is a successor of SSL. Earlier we are using, I think most of the person who used SSL, now you are using the TLS. TLS is a connection level protocol designed to provide the security for the TCP connections, right? Suppose you are accessing any website, then it is a totally secured. You are getting those things in the browser. This is TLS connection is there. So TLS is a cryptographic protocol to establish a secure connection between the two systems. It means client and server, right? So TLS provide mainly three features like authenticity, like client and server will know each other, and confidentiality, where data transfer between the client and server is encrypted, and integrity means no data loss between the client and server. So TLS guarantee authenticity, but by default it happens in one direction only. This is the main feature, one direction. Means client authenticates the server, but server does not authenticate the client, right? This is the TLS. So due to this reason, mTLS comes in the picture here, because in microservices we require the mTLS, right? So this is the how it TLS is working for that. So I've added the steps here, 1, 2, 3, 4. You can go and check how it is creating that handshake between the client and server. How it is happening. So I've created this diagram for that. And now for the mTLS, this is mTLS, the mutual transport level security is happening here, right? So mTLS is a regular TLS. Only one extra condition. This is what is the extra condition? Is client will also authenticate. This is additional functionality which we are getting in the mTLS only, right? So what is happening in TLS? TLS guarantees the client authenticates the server, but server doesn't authenticate the client. This is TLS, right? But mTLS is authenticity symmetric. Meant suppose Firefox browser identify who is Istio.io. When suppose we are accessing Istio.io from the Firefox, so Firefox browser identified who is Istio.io, and same time Istio.io also check who is Firefox, who is the client. Right? This is the only difference in both TLS and mTLS, right? So mTLS is basically required, is important in the microservices and API call, right? So this is the last slide for that. It is sub security architecture for that. It is same as the architecture only, which is showing the how security will flowing over there. Same thing, it is showing control plan, data plan is there, and control per Istio is a major service which is running over there. And you can see the certificate authority is there. Certificate authority will give the certificate to the each proxy and create the mTLS connection, right? And it would create the authentication policy, authorization policy, network configuration, because it creates the own network for that. That is that. And every thing is happening with mTLS format. You can see this one, and this one, right? So this we have done. I think introduction portion. I think I'm taking a lot of time for that, but it is basically required. I'm trying to cover those basics over here. And if you like this video, please like and subscribe my channel. So in the next part 2, I will cover that how to create AWS EKS cluster using the EKS-CTL command. This is the main thing, EKS-CTL command, right? How to do it, how to create it. So thanks for watching this video. We will meet in the next part. And bye for now. Thanks for watching.